Okay, optimization. So let's walk through these examples. We've got a concentration of a blood drug in a bloodstream given by this equation. So we're going to find the derivative. So product rule, first, second, etc. Write it out. You could factor it to make it simpler to type. You could write it the Excel way. I've gave you that option in class today. Let's get to the Excel, see how we're going to use Excel to answer the question. So we're going to create a table of values for these guys, and I've typed it into Excel both ways to illustrate that. I didn't handwrite it, but once you create your table of values, you are looking for where the derivative, so C prime is the notation, changes from positive to negative. It switches signs. So between 50 and 70, so that's the part C here, between 50 and 70 we see that that derivative changes signs. And that's the new thing for Unit 2 that we're going to use for the IV, the initial value when we do goal seek. Rather than some random choice, we need to narrow down our choice to better make sure we get the answer. So down here, I've done my goal seek. So with my three different initial values here, you can see the result of the time and the concentration of the drug. And you can see all three of those. So I did the 50 at the end, 70 at the end, and 60 in the middle, all give me the same answers right there. And our handwriting for goal seek. So we've got the equation in the first part. So I want you to realize that for the test, you don't have to write the same equation over and over again. So C prime of t equal to 0. We goal seeked. I picked one of the input values, so I'm not going to write a bunch of stuff. I found the goal seek answer of 59 point, etc. minutes. And then I wrote my answer out to both parts. And I realized after I did this in class that there's part of this I am not showing my work. I will deal with it on the test. May change it in the future, but for now, that's one of the reasons why I do this part B with everything, so that when I do the goal seek, all of these answers are done at the same time, and I'm not really doing them independent. Technically, the work for this does not involve the derivative, but I realized that after I taught it, so let's deal with it. Okay, example 2. Example 2 was a much more complicated equation, primarily due to our variable being in the denominator. Even after we simplify it, we've got that variable in the denominator. Okay, so let's back up. We are now dealing, I can't edit that out. We're dealing with a cost function, and we're dealing with an average cost. So we take our cost function, divide by the input variable, in this case x. The bar on top of the C is the notation for the cost function. So our question ultimately is minimize the average cost. So again, minimize, maximize, large, small are clues to find the derivative. So part B. So the algebra simplification we did was to help us with the calculus to make it a lot easier. You do not want to do the quotient rule with this and then type that derivative into Excel, whereas this is a lot easier to take the derivative and type it into Excel. So it's a choice you can make, but if you can make some parts a lot easier, make that choice. We're going to do exactly what we did before, construct the table, determine the two values where it changes sign, and okay, I could have clicked that before. Sorry about that. Not going to edit it. I'm rushing through. Okay, so the previous example and this one, I'm constructing a table to help me get the IV value to use with goal seek. So the construction of that table is kind of arbitrary. For this one, I picked between 0 and 2,000 in increments of 100. The previous example, I picked 2 hours, so 0 to 2 hours every 10 minutes. That's something you're going to have to figure out in context. How do I do that? You don't want it too large, you don't want it too small, you don't want the increment too large or small. So that's something you've got to work on in context. to example 2. So example 2 is a little bit more complicated because of the divide by, like I said, up there. So when we create our table, and I've got 0 to 2,000 increments of 100, and we're looking for where the derivative is changed, positive to negative. And you can see that our input we're off by a 100. And the reason I've got my graphs here is you can see that as that input value gets larger, that looks really horizontal. So that's why we're going to have problems with goal-seek. Now I zoomed in a little bit and you can see clearly that there is a minimum. Hard to see on the left graph, but there clearly is a minimum over here, and we're going to slowly work down to it. So initially I've got my 1300 and 1400, and you can see my initial values. So they barely changed. When I did 1350, my goal-seek didn't change at all. When I did 1400, my goal-seek didn't change. But I have a new pair, so I'm accurate within 50. So I've repeated this one with goal-seek also. That's why I've got the initial values listed there. And it's narrowed down to between 1350 and 1375. So I've gone from 100 to 25, my accuracy. And then I just, like I said in class, price is right, a little too high, a little too low. I'm guessing a little bit. Finally, I get to a place where you can see that's the average cost column, and that's what we're trying to minimize. And you can see all three of those give me the exact same answer. I picked the 1365 to use for what I wrote down. So, and I did make a note over here that thanks to Grace, if you're listening, that's a shout out to you. Sorry, my goal-seek didn't work. So I did this thing that my teacher told me to do, and then I still wrote some things. So we've got the equation up here. You don't have to write it over and over again. I've got that equation equal to 0, so just my notation there, C bar prime. I've got the value that I could have used with goal-seek that gave me the exact same value. And then finally I've got my answer here, the same. I didn't show my work for that part, and that's the end.